Good morning, good afternoon, good evening, wherever you are. Greetings and salutations. I want to thank everybody for joining another one of our webinars today. Continuous packaging, securing end-to-end delivery from build to production. My name is Christopher Black. I am a solutions architect with CircleCI. Joining me are a couple other technology professionals. Tom Gibson from Cloudsmith. Tom, if you want to introduce yourself.
Hey everyone, so I'm Tom. I work with Cloudsmith as a senior staff engineer, and I've been with the company around about a year and a half or so. My background is predominantly kind of quite varied. You know, we separated kind of 50-50 between a DevOps type background mixed in with a little bit of fintech just for good measure as well.
Fabulous. Thank you, Tom. And Larry Eichenbaum from HashiCorp.
Hello, everybody. I'm Larry Eichenbaum. As mentioned, I'm with HashiCorp. I'm there going on probably close to a year and a half at a prior software shop before that. Been working in a DevOps space for about 10 years. Lots of time in fintech. I spend most of my time today in public sector, and glad to be chatting and presenting to you today.
Love it, love it. Well, thank you both. Let's do a quick overview. Oh, well, here's our pictures. Let's do a quick overview of today's agenda. So we're going to spend a little bit of time talking about CircleCI, who we are, our mission statement. I'm going to spend a few minutes talking about a couple of pertinent platform features to help you all get started in your CI journey. We're going to spend a lot of time talking about Cloudsmith, and we're going to kind of wrap things up talking about HashiCorp, and more specifically, a really awesome technology called Terraform Cloud. We're going to dive deep into combining continuous packaging with integration and delivery. We're going to run, Tom's going to run through a demo, and then Larry's going to kind of tee things up using infrastructure as code techniques to build, stage, and deploy. And that's where we're going to talk a lot about Terraform Cloud, the Terraform Cloud integration. And then hopefully, if the demo gods are with us, we're able to stay on track with time. We'll save a dedicated 10, 15 minutes for Q&A. All right, cool. So this is the part we're going to talk a little bit about CircleCI. So hopefully many of you, most of you are happy CircleCI customers, perhaps heard of in passing, used for a one-off open source project, but today we're going to leave no stone unturned. So CircleCI is a continuous integration platform. Spoiler alert, you hear it in the name, CircleCI. And our mission is to make it as easy as possible to go from idea to delivery, effectively narrowing the distance between idea and implementation. And that's where rock solid DevOps practices come into play. Sophisticated automation, having a rock solid CI/CD pipeline. And the way I like to describe it is in a perfect world, obviously the world isn't perfect, but you know, a product person, somebody with an idea to bring value to customers, how quickly and seamlessly can we get that idea, that feature, that product, that service into the hand of end users? That's where strong continuous integration comes into play. I have to constantly update the slide because we're growing like heck. Every time I run through a webinar or I do a presentation, we have been doing this for a long time. We were founded in 2011, even though we're still very much a lean and nimble startup, and we have our pace of innovation is very much reflective of that. We've been doing this for a long time, and I think it's safe to say we're leaders in continuous integration. And when you think about the complexity, the sophistication of our cloud platform, we're by and large the largest cloud native CI/CD platform in the world. I think we're currently at 390 employees. Again, we're growing like heck. I have to constantly update these numbers, and we're a globally distributed company. We have offices all over the world, and this just means we're better able to serve our customers. And one really compelling example of this is our world-class support team, because we have engineers, support engineers, customer-facing support engineers located all over the world in various time zones. We're able to operate with really tight SLAs and just better serve our customers. And our mission statement is pretty simple. It's one of the reasons why I've been with the company for so long. I've been with the company for about five and a half years. I've spent most of my time, most of my career in software in a DevOps space, doing predominantly DevOpsy, infrastructure engineering, DevSecOps. And I've worked with a variety of companies of all shapes and sizes, from twodudesandapizza.com to some of the world's leading technology companies. But our mission statement is to help teams build better quality software quicker, more reliably. I already said we're the world's largest shared continuous integration platform, and we're going to talk a lot about the flexibility, the ease of use, and how easy it is to get started, how CircleCI can benefit folks who are running very straightforward one-off open source projects, perhaps for school, for learnings, for science, and we're able to serve some of the world's leading technology companies. On our cloud platform, we're currently running 1 million builds per day, and the terms build and jobs these terms are very much interchangeable. And when I dive into some of the platform specific features, I'll elaborate a little bit on some of those terms of art. But think of it like this: we're running 1 million plus builds per day on the platform. And if you think, that's probably an order of magnitude larger than some of the world's largest other CI platforms in the world. And then at the bottom here, you see a nice cross section of some of the customers we do business with. I like this because it's indicative of the various cross-section of companies that we're able to serve. Some companies here are what you might consider traditional technology companies, others aren't. But everybody is benefiting tremendously from the great digital transformation, from adopting DevOps practices and bringing this into their organization. And so I like this visualization because this shows where CircleCI fits in the overall tool chain. We sit very comfortably kind of in the middle of the overall SDLC, very comfortably in between creation. That's your source materials on the left. That's some kind of generally some kind of get back version control system. That's the raw stuff that we use to produce software, and then logistics all the way on the right. And logistics runtime environment. The runtime environment can be many different things. It could be an EC2 instance running on AWS. It could be physical bare metal infrastructure. It could be a mobile device. It could be a Raspberry Pi. But when you think about all of the mission critical activities that go into taking source material on the left, building, testing, deploying that securely, at scale, deterministically, to some kind of runtime environment on the right, there's a lot of core high value activities associated therein. And again, that's where CircleCI comes into play. So let's talk a little bit about some of the core features that I think set us apart as a platform. A couple of features come to mind. First off, we have an amazing UI. So developers are going to find everything they would expect to see in our UI, everything from build output, a lot of meta build information like the person who kicked off a workflow or a pipeline, what resource class you're running your job in. I'm going to talk a little bit more about resource classes in a moment. If you're running a workflow, the terms workflows, pipelines, these terms are very much interchangeable, but as you can see here, the shape of your workflow, for example, all of this is going to be made available in the UI. And then we're going to talk a little bit about a powerful feature called Insights, which is how you're able to get very pertinent build telemetry, metrics, information into your overall CI process. These are the kind of things that you're going to be able to see in the UI. We have a robust API, of course. So most, if not all of the actions you can take within the UI, you're also able to achieve via API. And this is great because it just expands the surface area of our platform for more and more automation. And then lastly, we have a CLI. If you're a CircleCI user and you don't have the local CLI installed, pause this video, stop, hard stop, download the CLI. It's a really powerful tool. You can use it for a couple of really powerful things. One, validating the syntax of your config file. I think that's generally best practices. When we talk about orbs, pushing and pulling orbs from the orb registry, shareable, templatized pieces of CircleCI configuration, you're going to do that locally with the CLI. And then being able to run Docker jobs locally before pushing things upstream and actually triggering a pipeline on the platform, or just a couple of use cases associated with the CLI. So those are the first things that come to mind. One of my favorite features to talk about, we call these configurable resource classes. A resource class is effectively a mapping to an underlying executor type in terms of the number of cores and the amount of RAM we make available to that job, to that build. And so an example would be, let's say you have a computationally intensive build, a computationally intensive job, maybe Android, Java, JVM, computationally intensive. We have a lot of tests. We're probably going to need to run that on a large resource class. That is to say, we're probably going to need to allocate, let's just say I'm shooting from the hip here, 8 cores, 16 gigs of RAM, right? Java, JVM, computationally intensive. We're probably going to need a little bit more horsepower for running a job like that. Now, the inverse is very much true. There are many opportunities to run builds on a small resource class. For example, let's say we're doing some kind of static code analysis. We're using Terraform open source to apply infrastructure to AWS or GCP. Well, Terraform is a very powerful technology, but under the hood, it's just making a lot of API calls. We wouldn't need to run that in a computationally intensive environment. When we talk a lot about our platform philosophy as configuration as code, all your project-specific configuration is going to be stored in a declarative YAML file. You're going to configure what resource class to use, of course, in your config file as well. Concurrency and parallelism. I always struggle with the word parallelism. I don't know why. It's a tongue twister. So try saying it 10 times fast. but effectively the ability to, let's say you've got a very large test suite. I'm also kind of shooting from the hip here. Let's say you've got a very large, extensive automated test suite, 100 tests, 1,000 tests. The ability to distribute and to test split and parallelize those various tests across however many nodes you specify in your configuration file can, generally speaking, dramatically cut down on the overall time, on your overall build time. Very powerful tool. And then concurrency means being able to run many, many jobs in parallel. Slight distinction between the terms concurrency and parallelism. Parallelism is generally used in conjunction with test splitting. But when you put these two concepts together, running many jobs concurrently, and then some of those jobs with exhaustive test suites, being able to run some of those in parallelized fashion, when you specify however many nodes in a pipeline, can dramatically cut down on your overall build time, thereby amplifying the developer feedback loop. All right, Matrix builds. Word on the street is that they're filming Matrix 4, but I digress. So Matrix builds, Matrix jobs, this is a developer's secret weapon for taking relatively simple config and using it to build very sophisticated software. And I'll give you an example. Let's say you're testing multiple versions of Node.js. There's a million versions of Node.js, node modules, etc. But let's say you're testing multiple versions of Node.js, or Go, for example, multiple versions of Go. And you want to make sure that your tests run on both Linux, and Mac. There are a number of ways you could configure that using parameterized config, or you can leverage a function called matrix jobs. And if you'll see here, hopefully some of you can see the cursor, but if you look at the config example on the right, under parameters, you see an array of different operating systems. And then you see a couple of subjects at the bottom, both of which are arrays. But what happens is with these two arrays is that we'll create a Cartesian product, we'll produce a matrix, if you will, of various testing environments, etc. So like I said, it's a very convenient way to test sophisticated software paradigms. Can't talk about cloud native CI/CD without spending a couple of minutes talking about security. Security is and should be top of mind for all organizations, irrespective of industry or vertical or team size. I'm sure many of you are familiar with the concept of shifting left, baking application security earlier junctures in the software delivery lifecycle. Very, very important stuff. And so, of course, security is top of mind for us at CircleCI. We hold a number of prominent security certifications we've worked really hard to achieve and we're very proud of. Some of the big ones that come to mind, obviously, we're GDPR compliant, we're SOC 2 certified, and then there's one certification on the lower left-hand corner some of you might not be familiar with. It's called FedRAMP. It's very much SOC 2, but specifically for federal entities. So in the United States, like most governments in the world, there's a big initiative in the federal space to modernize how they build, test, and deploy software, which is great. So the great digital transformation is affecting organizations, even in the federal space. That's wonderful. The FedRAMP authorization allows us to do business with some of these organizations. And so I think that's very indicative of our overall security posturing. A more kind of concrete example of how we handle security in CircleCI is every time you run a build or a job, we're going to check out your code from source control. We're going to provision an environment. That environment's either going to be a Docker, it's going to be a containerized environment, or it's going to be an ephemeral virtual machine. We're going to check out your source material, and then we're going to execute whatever arbitrary commands are specified in your config file. At the end of that process, at the end of your job, at the end of your build, we're going to destroy that environment. Now, that environment is isolated both at the network level and at the C group level. That is to say the processes are isolated. And anything that is not explicitly persisted, that is to say artifacts, deployment targets, test results, etc., anything that is not explicitly persisted is going to be destroyed along with the source material, along with the output, along with the environment itself. So not only does this lend itself to very strong security posturing, but it also lends itself to a deterministic CI environment as well. You run your build in a fresh environment each and every time, and the premise being we're alleviating the tried and true, well, it works on my machine locally. I'm not quite sure why it doesn't run on Tom's. Tom's, I'm sure an industry veteran such as yourself, you've heard this once or twice in passing. Diving a little bit deeper into secrets management on the platform, we have a very powerful feature called context. Now, Contexts are shared groupings of environment variables that are set at the org level. Now, these examples of some of these environment variables might be AWS deployment credentials, for example, a Slack token if you have a custom Slack notification. Any kind of secret that you'd need to integrate with a third-party tool or service, you're probably going to store this as a context, not to be confused with the Kubernetes context. They're shared groupings of environment variables, and we mount these contexts to individual jobs in a workflow. So an example being, let's say we have a simple pipeline, build, test, and deploy. We're only going to expose our secrets to the deploy job, right? Makes sense. We don't need the build or the test stages, if you will, to even have those secrets present in the runtime environment. And then Larry, our friends at HashiCorp, hopefully you're listening to this, our context feature is built on top of HashiCorp Vault, which is an industry-leading KMS technology. Oh, also, before I forget, we also have a very powerful feature that enables you to rotate context programmatically using the CLI or using the API. So when you think about very kind of sophisticated, cutting edge, dare I say, use cases around security and secrets management, what you see a lot of folks doing is automatically rotating secrets every N interval using some kind of out-of-band service or integrating their own KMS technology. But all of that's possible on the platform with the API and the CLI. All right, I'm almost done with my bit here, I promise. Last feature I really want to highlight is a feature called orbs. What the heck are orbs and why should you care? This is just a nice visualization of our configuration hierarchy. So our philosophy as a platform is all of your project-specific configuration is going to be stored as a declarative YAML file that lives in repo. And this makes sense, right? You're able to leverage all the same benefits associated with storing source material and version control. That's great. Okay. All on the same page there. All the same benefits you'd get to using Terraform to store your infrastructure in declarative modules, for example. When I say your project-specific configuration, I mean the shape of your pipeline. If you're running your build inside of a Docker image, what Docker image are you running your build inside of? What are the steps that I'm going to execute inside of my jobs when I run builds? All of this is going to be defined in your configuration file. But once upon a time, there was a problem. Every project had to have its own configuration file. And this was the case for years. And that's fine if you're in an organization with a couple dozen projects, maybe 100 projects. When you start to think about larger organizations that have many hundreds of projects, the notion of writing a configuration file from scratch for each and every one of those projects doesn't scale well. It becomes cumbersome and unwieldy. And then, of course, many of you are probably thinking, well, what if some of those projects share common patterns and steps and paradigms? So for all those reasons and more, we built a feature called Orbs, which enables shareable templatized packages of CircleCI configuration. The simplest way I can describe Orb is a package manager for CircleCI configuration. So aside from many of the inherent benefits of just drawing up your code and being able to encapsulate common patterns, what we found is that it opened up the doors for this ecosystem, if you will, of integration points with third-party tools and services like Cloudsmith, like HashiCorp. If you take a look at the Orb registry, you type in your favorite technology, I would be shocked if you didn't find a CircleCI Orb for that technology. And what's really exciting about this, again, aside from the inherent benefits of just writing cleaner, more deterministic code, being able to onboard new projects quicker and with less friction, is that you're now able to integrate with exciting third-party tools and technologies simply by referencing the Orb in your configuration file. You pass in a couple of parameters, boom, you're good to go. So this is a nice example of some of the integrations we have with a wide range of technologies, tools, services, third parties. It's really exciting when you think about, can I integrate CircleCI with X or Y or Z for that matter? Chances are there's an Orb for any of those. All right, I've been talking quite a bit. I think, Tom, this is where I pass the baton to you.
Awesome. Thanks, Chris. Thanks so much. So yeah, just to recap, I'm Tom, and I'm here today with Cloudsmith. So for the benefit of those who don't know, Cloudsmith is a fully cloud-native package management service, and we try to position ourselves as right at the heart of the development and operations functions. So today I'm here to talk about how Cloudsmith can fit right in between your build and distribution and deploy pipelines, and in doing so strengthen the security of your software supply chain. So let's kick it off then. So next slide, please, Chris. So first off, a little bit more on Cloudsmith. So, I mean, the important numbers here are up on the right. We're a company headquartered in Belfast in Ireland, so immediate apologies for my accent here. I promise I'll use my best telephone voice throughout. But being completely cloud native, our big benefit here is our package delivery network, and you'll hear a bit more on that in our slides to follow. But bottom line is, we work super hard to ensure that our service works as well in Sydney as it does in the East Coast of the US and everywhere in between. We're operating in around about 225 points of presence right now. And, we locate our infrastructure kind of with regional cache access in mind. So, performance and latency are always at the forefront of what we're thinking. There's a bunch of concepts you're going to hear me talk about today throughout this piece and also the demo, such as, single source of truth and continuous packaging. And I promise, this isn't all marketing mumbo jumbo. These are intrinsic concepts to our product and what we want to do for our customers. And we'll discuss this as we're moving forward. So we see package management as being right at the heart of the DevOps ecosystem and kind of like the glue between development and operations, like we discussed. And, we work to integrate with tooling across the whole spectrum of the pipeline. So you'll see a couple of the ways in which we do that on the screen right now. But, first off, we're a universal, service, truly universal. We currently work with around about 25-ish package formats, and, that number's going up all the time. The gamut of kind of formats that developers require, we strive hard to support, and it all ultimately guiding towards the goal of allowing that single source of truth. And we've no imposition on how these repositories are used. We'll allow Terraform modules to coexist with Docker images and Helm charts, and or Debian packages to live alongside Alpine packages and RPM. The choice is up to you, and we want to empower our customers here. Next slide. So next up, we're going to talk about the role of Cloudsmith has within your security supply chain. So, we've mentioned this. We want to be seen as a single source of truth for software and dependencies that isolates and protects, you and your teams and your customers from supply chain attacks. And that's something obviously that's highlighted and strengthened as an argument ever more. So next slide, please, Chris. Starting from the left, and we want to go through a flow and how we can do that. Starting from the left, we have developers and teams here contributing to a product, and they'll be following best practices ultimately about, as Chris mentioned earlier on, shifting security as far down the left as we can go. So they'll be making use of CI tooling such as Circle, performing unit tests, static analysis, all that good stuff, that we've become ingrained in the process of development and what we do. As part of this process, builds our artifacts are pushed to Cloudsmith continuously. And when we take in a package, we'll kick off a process to make sure that all things are good with this package. We'll perform some malware scanning, signature, checks and verification, all that. Everything that you would expect at that point, vulnerability scanning then for Docker images as well. Dependencies for the application are isolated in this sort of approach. And so, with access to public upstreams no longer required, the whole flow is what we call continuous packaging, and it sits in tandem with integration and delivery. You can see here, we've got this idea of rejecting bad packages that we've identified as, not what we want, and promoting the stuff that's good and passing it through to the delivery pipeline. Moving on to the delivery phase, still within Cloudsmith, we can perform promotion to environments. And so in this little flow, we'd maybe promote to a staging environment for some testing, where ultimately then we would progress to a release. And our package delivery network sits on top of all of this and gives access to your users and your customers through trusted ways. Using the process of continuous packaging, we allow the observability and control as a priority, ultimately, to ensure your software is verified and ready to deliver. So we've touched on the security stuff, in terms of vulnerability scanning and signature and all that kind of thing. That's super important. It's really, really critical for us that we do that. But bolstering the notion of single source of truth, we provide ways in which you can proxy and cache assets from upstream sources, and everything in the system's traceable. So we have a full provenance trail right the way through from start to finish for every asset that has been pushed onto Cloudsmith, and you can use this to determine how something got there, when, and who did it. Okay, and on that note, visibility of the system is critical. So, access to download logs, bandwidth statistics, etc. We ultimately try to give you a 10-foot view of where your stuff is going. And so if you're a vendor, say using Cloudsmith to allow access to licensed software, we can give you detailed information on where that license is being used, how often, all that kind of stuff, and finally, to finish off, there's webhooks here within the system. This allows you to essentially reach out to all of the observability platforms and pipelines within your tooling, or even driving other systems such as CI, which we'll see in our demo, or even customer relation management software as well. Okay. And you'll see the notion of the word package delivery network, and we're essentially talking about a smart CDN in this sense. Cloudsmith is a smart CDN focused exclusively on package management and the issues and problems that customers face in that scenario. We've already touched on the points of presence type stuff here, but we've really tailored things here to be quick, right the way down to the stuff that happens in each of the edge nodes, and right the way through from start to finish. We're looking at provenance, we're looking at access permissions and security. So with entitlement tokens, for example, you can lock things down in the sense of saying, okay, well, I want to allow a user to access version 1, but not version 2. And we support that, with a very, very powerful query syntax, support sort of semantic versioning and all this kind of good stuff as well. Finally, we let you present this PDN as your own, so you can brand this through custom domains. You can make this appear as, hey, that I want to appear today as, and you'll see this in example. I'm not going to names just yet, but ultimately this is about kind of presenting the PDN as your own, whether that's for internal development or distribution to your customers. Okay. So that just about covers our flyby of who Cloudsmith are and what we do. Takes 60 seconds, we've timed it, to get up and running with a 14-day free trial. So feel free after this to go right ahead and do that. So thanks, Chris. I'm going to hand over now. Yeah, cheers.
And thank you, Tom. I'm Larry Eichenbaum again. I'm going to try to go a little bit quick to try to gain some time back for a demo. So if you want to just jump to the next slide. A lot of users in the DevOps field, and probably a lot of people listening here, have heard of a lot of our products. A lot of people very often don't relate the products back to the company. HashiCorp is a company that created Terraform. We've created a lot of other really great products called Vault, Console, Nomad, and some really new releases, Boundary and Waypoint, that are very exciting. I wish you would go check them out. But we're a pretty established company, even though we're only founded in 2012. Next slide, please. And one of the very interesting things about HashiCorp, and the obligatory eye chart slide, but the reality is probably everybody listening here is working with and using, unawares to you, a HashiCorp product every day between the time you wake up and the time you go to sleep, whether you're turning on your TV and your cable box, or getting a coffee, or checking your stocks or your bank account, or turning on your car, flying in an airplane, traveling, etc. Those systems, those vendors, those companies very often are trusting HashiCorp products under the covers to provide the security around their data, as well as to build the infrastructure that enables and powers all of their applications and systems. Next slide. What I want to focus on today, and again, I'm going to try to go a little bit quick, is the aspect of Terraform, specifically Terraform Cloud. Terraform is a tool that is used very commonly in the industry. It's often thought of as a Rosetta Stone. It bridges provisioning and deploying of applications across all the different cloud platforms and on-prem, using a consolidated language and workflow so that your staff and your operations team can be more efficient. Next slide, please. And provides those staff and those operations teams to be able to do so in a very safe, controlled, and compliant manner. Enables you to be repeatable and predictable about everything that you're building and deploying. And so I want to highlight 3 core features that we're going to be leveraging during our demo portion today. They really are talking about state. When we talk about state, and I'm not going to read slides to you, but state is all about keeping track of and identifying everything that you are provisioning and deploying, so that your tools like Terraform, can then maintain that state and then track any deltas so that you can correct for them if needed. One of the big differentiators with Terraform Cloud versus open source that a lot of users use is how you manage and secure that state. That state can contain a lot of very important and crucial data that you want to keep secure. Things like SSH keys, cloud credentials, database passwords, the IP addresses for the systems in the cloud that all of that data applies to. Terraform Cloud and our enterprise products protect all of that state in a very, very secure manner. And this is very different than open source, and it's something that everybody should keep in mind. Next slide, please. Another feature that we would highlight within Terraform Cloud is this capability of cost estimation. And it enables your teams to be proactive and preventative in terms of what they're deploying. As organizations move to the cloud, one of the biggest problems they have is cost overruns. They find that as they move to the cloud, their costs explode because they don't have any guardrails in place to allow controls over how you're deploying and what you're provisioning. Our cost estimation feature makes that really very easy for them. Next slide, please. And our policy as code feature is another very key element. As you deploy infrastructure to the cloud, you want to ensure that you are remaining within those guardrails of policy and governance rules that exist in your organization. Our policy and code lets you define that policy as code and then proactively enforce that policy and determine whether or not what you will provision is compliant or will be compliant before you provision it. And that's very different than a lot of other tools in the industry where that evaluation is completed just after a deployment. From my perspective, you can't put the genie back in the bottle. So it's important that we do these things in a preventative manner. Next slide, please. When we start adding all of these together and you leverage infrastructure as code and policy as code, it becomes a very, very good benefit also to leverage that through the cloud. And what we're going to see today in today's demo is the deployment of these containers and applications and provisioning of infra, leveraging our Terraform Cloud platform. And with that, next slide, please. Thank you very much. And let's move on to demos.
Awesome. Awesome. Thank you much, Larry.
Awesome. Thanks. So I'll kick off then. I'll share my screen. So I'm going to kick things in now. You guys see the presentation okay?
Yep.
Yeah, awesome. Okay. All right, so bear with me. Okay, so I'm going to go into presenter mode real quick for this. Okay, so what we're going to do today, ultimately as part of today's demo, is go through a scenario that we see play out among many of our customers at Cloudsmith. And first off, I want to introduce Waffle Corp. So to be clear, before any patent infringements start coming my way and all that sort of stuff, Waffle Corp's a fictitious company. There's no legal representation, just waffles. Okay, so look, this is a hypothetical situation, right? And the hypothetical situation is that Waffle Corp are the creators of an application called Sturdy Waffle. Okay, and it's the world's finest cloud-based network security appliance. That there is. Absolutely not an auto-generated GitHub repository name, but we're going to look at how Waffle Corp is using CircleCI with Cloudsmith to do secure build and distribution of their software product to the world. Okay, so the application in this case is a simple Python application. It's a Flask-based front end. You can see up here we've got a screenshot of the root structure. We've got a requirements file for a pip lock file. We've got setup tools, configuration. All this will look very, very similar and familiar to people that are in the know of Python development. But this repository is hooked up to a CircleCI pipeline also. And in that, we've got a couple of workflows defined. So we want to start to talk just about what the overall flow is that we're going to be showing here today. And, and in this case, how Waffle Corp actually publish out a release. So what we're going to do here from start to finish is the release of that. And that is initiated using the push of a Git tag. Okay, so Waffle Corp ultimately creates some Debian system images, system packages for their applications. Now, from those that probably do some testing, and they may even reuse those for on-prem sales or something. But the primary model here is to distribute a self-contained Docker image to customers. And they do that by building an image within the pipeline, scan that for vulnerabilities, and then promote to release. And so we're going to be looking through those steps within our demo today. Okay, so I'm going to break out of present mode and flip over to our friend over in Cloudsmith repositories. And so, inside Cloudsmith itself, you'll see it on our page here. We've got an organization for Waffle Corp, and within that, there are 5 repositories. So we've got an application repository just here, if you can see what I've selected, and that's where we're going to be storing our built Debian packages. We have a build images repository as well, and we maintain a set of images that are utilized for executors within CircleCI, as well as the base image for the distributed Docker image also. We have a dependencies repository where Debian dependencies for our application are stored. A staging repository that's where images, Docker images that have been built will live before they have been promoted to production. In the demo, we'll be gating this by way of a vulnerability scan of the image. But in the real world, we'd probably be utilizing something like Terraform to provision this out into infra and maybe utilize CircleCI orbs with Postman, for example, to do end-to-end tests and all this kind of stuff as well. And so I guess let's get started then. So first off, I'm going to look at the release process. I'm going to begin by kicking off a build of the Debian package itself. And so that's at the minute, this sturdy Waffle repository, that's orchestrated using the push of a get tag. So if I take a look, we've got a whole bunch of tags in here already. So I'm going to put the next logical variant up here and push that up to GitHub. And we'll flip over to CircleCI in the browser whilst that carries on. And we'll see momentarily that there's a workflow has just been kicked off, okay? And so there's 2 jobs in here that have been defined. We've got a build and a publish job. Let's step through, I guess, what's going through each one of these jobs. So first off, we're utilizing the Docker executor within Circle, and this is using a sort of custom image based off the original CircleCI Python images themselves and hosted on a private registry within Cloudsmith. And as we're utilizing private registries, there are credentials involved. And so we're making use of CircleCI contexts in order to actually secure the secrets that are utilized to do that. The job itself is very simple. We're writing out the tag for the for this actual release out into a file, and then utilizing an open source tool called FPM to package that Python package into a Debian system package instead, and finally persist that out to the workspace using the persist to workspace step. And this allows us then to pick that Debian package up in a subsequent publish job running within the workflow as well. Okay, so the publish job within the workflow, it makes use heavily of the Cloudsmith CLI and the orb, the Cloudsmith orb, to do just that. And so we have a couple of commands within the orb, stuff that helps to sort of ensure that you've got an API key set up and the CLIs and so on. You can see those are referenced as steps within this job itself, but we're ultimately going to attach to the workspace to allow us to retrieve the package from our previous job. And we'll utilize the publish command within the Cloudsmith orb to actually push that package all the way up to Cloudsmith. So we've parameterized this particular job to take a repository and a distribution. And in the real world, we would likely be using a feature such as Chris has highlighted earlier with matrix builds, for example, in order to perhaps push up huge variants of these sorts of things in terms of targeting different, perhaps Ubuntu or Debian variants or something with these systems packages. But today, our workflows configured to essentially just send the one for the purposes of the demo. Okay, and so that should now be complete. So I'm going to flip over to Cloudsmith and go into the application repository, and you'll see at the top, we've just got 142, the tag we've just pushed just recently. And so I'm going to go into this package within Cloudsmith, and you'll see at the very top here, we've got all the pertinent information related to checksums and validation and all that kind of stuff that we perform at the point of synchronization. And at the bottom here, there's a couple of dependencies that are mentioned, and these have been brought in as defined in the Python setup tools script itself. So there's a direct dependency here for the Flask library as well as GUnicorn that's used to serve it out. Now these are just direct dependencies, like all software built today, or most software built today. Dependencies will bring in indirect dependencies, right? It's a natural sort of progression, and that's sort of, I guess, leads us on to the next point in our flow in the building of the Docker image itself. So I'm going to start by looking at the Docker file that's used to create our image. And there are two you'll see up on the screen. At the very top in the terminal, we've got a base image that's going to be sort of built and pushed up to the build images repo. And at the bottom, in this case, is the application Docker file itself. Now, in both cases, we're bringing in the Cloudsmith repositories. There is the dependencies repository here and the actual Sturdy Waffle application dependence library or app, here. And, in both of these cases, we're invoking the Cloudsmith scripts to install these repositories. And, they do a bunch of things. They ultimately pull down the GPG keys from Cloudsmith for both of those repositories and install them within the system. They create apt repo entries for each one of these and then sort of update the system. You'll see as well, one of the layers that we've got within the base image is to remove the sort of default apt sources repository. And the reason that we're looking to do this is essentially to ensure that all software that we distribute at the build phase, our dependencies are not sourced from untrusted third parties. We're looking to kind of direct it and make sure that all our dependencies are kind of piped through Cloudsmith and through our dependencies repository at that point. I'm going to, at that point, I guess, segue over and have a look at our dependencies repository. And you'll see that there's already, a bunch of dependencies that have been brought in at this point. Now, this repository has been configured to utilize the upstream proxying and caching feature within Cloudsmith itself. And so, it allows you to direct requests for packages that aren't yet in your repository to any number of upstreams. And these are resolved by the priority number that you see on the left here in the column. So there's ultimately a union of packages. You'll see we've got 36 packages in the repo itself. When an apt client will connect to this repository, it will see kind of the union of those packages melded together with what's available, in the main component and the universe component of the Ubuntu upstreams as well. And so upstreams themselves, they have two configuration modes. There's a proxy mode, there's a proxy cache mode. The latter is what we've configured with both of these upstreams today. And what this means is that when we request a package from Cloudsmith that isn't in this repository, we'll go ahead and automatically synchronize that and make it available in the Cloudsmith repository so that subsequent fetches for it are no longer required to go out to the world, essentially, in order to pull it in. And this, we feel, is a kind of really significant step in strengthening the software supply chain. One of the very strong ways in which we do it. So we're no longer reliant on public upstreams at this point to build our applications. So I guess now is a good point to talk about how we kick the build off for the image itself. Our application repository, where our Debian package has been stored, has been configured with a webhook. And this webhook is configured to point to CircleCI, and we're utilizing the V2 API in order to do that. And we're pointing to the pipeline endpoint here in this case. Now, webhooks allow you to kind of send events out after certain things have occurred. There's a list of them here that you can see. In this instance, we've configured it that when the package is synchronized, so when it's available to be downloaded, we want to tell Circle that, hey, this is ready. I want you to go off and kick off a build of a Docker image. And we send a couple of build parameters out to this specific pipeline in order to inform it that this is the specific workflow that we want to invoke at that point. Okay, so I'm going to flip back to CircleCI and have a look at our dashboard at this point. And you'll see we've got the build and publish app workflow has kicked off. And that was as a result of the webhook that was triggered from Cloudsmith itself. So we're going to have a quick look at the definition of this workflow. And this is a standard kind of create a Docker image, push to a registry, tag, all that kind of stuff. You'll see, many of you will have seen this time and time again in your careers, and it's probably not something unfamiliar. In this instance, we're utilizing native Docker tooling to push to Cloudsmith, but you could, of course, also use the Cloudsmith org to do so as well. So this workflow has already completed. And if we flip back to Cloudsmith and go to our staging releases repository, we should now see that 1.4.2, which is our newest release version, is now living in the releases repository for staging. And so at this point, this is kind of our gateway before we move on to the next part of our flow. Beside the name of the image, you'll see we've got a little shield, and that refers to the vulnerability status of this image. So every time a Docker image is uploaded in this configuration, Cloudsmith is going to perform a vulnerability scan. And this helps us kind of have a level of certainty over the security of the Docker images that we're going to be pushing out to the world. So we're able to identify CVEs and system and application dependencies. And in our case, we've installed a bunch of Debian packages, but this would also cover a use case of an Alpine base image with NPM sort of packages instead, that kind of thing. We sort of cover the spectrum of everything, as it were. And the scan information can be retrieved through the UI. If we click on the shield, you'll see results of a previous run here where we've picked up and we're able to present that. But this information is also made available via our API. So we've configured this repository in a similar way to our app repo, in that we're triggering a webhook. And we do that in this instance whenever the vulnerability scan process has completed. So that kind of leads us on now to talk about the promotion to release side of things. Okay, so I'm going to flip back to Circle and we're going to have a look. You'll see at the top, we've got the promotion workflow is now sitting ready to go. So this has been triggered by the webhook. I'm going to give you a quick overview of what's in here. Ultimately similar sort of scenario. We're utilizing the Cloudsmith orb here, and you'll also see a reference to Slack as well in this point. And the idea here is that we want to notify someone that an image is ready for release in this instance, and direct an approver to approve this release. So the job for our promotion workflow itself, and you'll see sort of further on down here, we've got a Slack on hold, a confirmation, so approval step as well, and then finally the promotion itself. If we flip over to Slack, you'll see that we've got this notification now sitting, waiting, ready to go. I'm going to click the button and view the workflow, which will allow us to approve this via Circle. And in doing so, the promotion job now starts to kick in. And behind the scenes, this is going to do a couple of things. Okay, so if we flip back to our job definition, we've got some stuff happening here. Predominantly, we've been given some parameters by the webhook that says, hey, here's where the vulnerability results are for this particular build. And we're utilizing just curl and JQ to pull that information out in order to determine how many vulnerabilities are in this particular build. So in this instance, we're looking to do a check to see that there are none. You could, of course, also set this based on, say, max severity or something like that. But in this instance, we're going, if there are any vulnerabilities, we want to stop at this point entirely. Otherwise, we'll invoke the promotion step. And in that instance, we'll use the Cloudsmith promotion command within the CLI to promote this to the releases repository. Okay, so at this point, we have actually initiated the approval. The whole workflow itself is completed. And if we switch over to our releases repository at this point, you'll see 1.4.2 is now sort of sitting ready to go. And this is now publicly available and ready to be pulled down in the wild. The image itself, if we have a look at the logs, you'll see there's kind of still the original sort of history as to where this image came from. And, we'll be able to tell you what repository it came from, when it was uploaded, who uploaded it, all this kind of stuff as well. And so that kind of ends, I guess. This is where we kind of leave Waffle Corp itself behind. We're going to skip forward a little bit now and talk about what we do on the other side of this workflow. And so to do that, we're going to introduce another company real quick, in this instance called Super Acme Corp, right? These names keep getting better and better, I know. So Super Acme Corp are licensed users of Sturdy Waffle, and they utilize Terraform Cloud to provision this within their infrastructure. So we've put together a bit of an overview of that whole model and how this is performed. So, Acme's deployment is pretty straightforward, right? It's provisioning a Fargate task within an AWS ECS cluster. So as we're accessing a private registry to pull our image, we've also configured an AWS secrets manager entry in order to hold these credentials. So the values for these actual credentials are all stored as variables within Terraform Cloud itself. So Super Acme themselves have been issued an entitlement token, in this case via Cloudsmith. And just to recap, that's a read-only key used to access assets within a repository. So if we take a look at the Terraform side of things now, you'll see that our Terraform is built up. The root module brings in two submodules, both living within Terraform Cloud, an app and a network module. And these are both configured then through variables. And some of these live in an environment file, if we look in here. And then some of the secret stuff then will all sort of be contained within Terraform Cloud itself. Okay, so we've just pushed a new version right now. This is a commit-based workflow within CI, so similar to what we've seen before. I'm going to go ahead and initiate a release of 142, which was the version that we just pushed. So by updating the tag in our environment file, I'm going to add this. Push. Okay. There's nothing more interesting than looking on the terminal, I know. But we'll flip back at this stage, and I'm going to jump over to the Super Acme Corp organization now within Circle. And you'll see we've got a deploy infrastructure workflow that's now just about to kick off. And this is a pretty standard sort of flow of things that we'll see. So we're going to do a Terraform init, which some of you who have used Terraform will be familiar. We're going to be pulling down the modules. We're going to be sort of gathering state and all this kind of stuff, and then perform a plan. So ultimately determine that what's up there right now in Terraform in terms of state versus what to apply this change, what actually needs to happen. And so whilst this is going through the motions, I'm going to talk a little bit about some additional workflow that we have here within our configuration that really sort of strengthens, why you may use Circle to do this kind of thing in the first place. And so we've got a workflow down here, a scheduled workflow that's scheduled to run sort of nightly. And in this case, we're going to go up and ask Cloudsmith for the latest version of the image itself and try and determine, what that is. And we'll do a comparison of what we've got in our local state. And if that has changed, we'll push the change over then into the repository, which will ultimately trigger the whole sort of deploy workflow once again. Now, we're making use of approval steps in each one of these across the scene. It's obviously very critical. You don't want to automatically apply stuff to the infrastructure. So it's great that Circle sort of provides this functionality in order to do it. I'm going to go ahead and approve the plan for our infrastructure deployment. And, if we open up the log information that's currently starting to come out of our apply step, when Terraform kicks in, we'll be given a URL which will tell us how to track the run that's currently ongoing. So I'm going to open this in a tab, and we'll see this start to take into effect. And I think at this point, probably best I hand over now to my co-presenter, Larry, with HashiCorp, who's going to talk a little bit about what's happening right now at this point. So I'll stop sharing now if I can.
Hello, everybody, and thank you, Tom. I believe my screen is being shared. Can somebody please confirm for me?
Yeah, I can see that.
Okay, and we see the Terraform screen. So what we can see here, as Tom was highlighting, from that pipeline workflow for the actual application of this infrastructure that is leveraging Terraform Cloud, one core element to note is the processing for all of that is occurring within the Terraform Cloud infra. The data is streaming, the output is streaming both in the Terraform Cloud, but also back to that pipeline so that you can see that output from within the pipeline. And so we can see here that the apply is actually running and now building up all that data. But what I want to do is I want to highlight a couple of quick items while this is running. And also, I'm probably going to go a little bit quick just looking at the clock. We mentioned earlier that state is really important. So everything that is being built here, there is state that is being written and populated that defines and specifies that infrastructure that is being built. What I'm going to do is look back at some prior states to show you some of the types of things that we can see within this state. And if we look back here at, actually, if we go back and look at this state here, this one here, we can see an earlier run during our demo where we had some infrastructure that was built and we had deployed a new version. And so that state that is fully secured within Terraform Cloud, we can see this data now because I'm logged in as an admin. We can see some changes or the deltas that occurred within that state file that reflect the changes that occurred within the infrastructure that was provisioned. But all of this state information is additionally fully secured through roles and access controls within the Terraform Cloud product, so that different groups or users that are using Terraform Cloud should only and could only see the state file for their infra if they're authorized and granted permission to do that. And that becomes really handy because you might want some users who are deploying and tracking the progress of the infrastructure, but maybe they shouldn't be able to view the state. They shouldn't be able to see what keys or credentials were used when infrastructure was being provisioned. And that's very, very critical. A couple other items that I wanted to highlight as well that we talked about in slides earlier is this cost estimation feature. So within Terraform Cloud, we perform a cost estimation. We can evaluate of the things that you've requested to deploy and provision, what's that estimated cost basis for these things? We can get into there and we can become a little bit more granular about the elements that are being provisioned. In this particular instance, we're doing a lot of Fargate resources, and Fargate resources don't have a cost unless they actually run because there's no physical infra that's provisioned for them. So those don't show costs, but some things like the load balancers do, and that's very, very helpful. Additionally, we can take everything, all of this output and results of cost estimation, and we can tie that into our policy checks as well, so that we can do things like enforce policy and governance rules around S3 buckets, around enforcing that you're properly tagging your infra, or maybe that the costs of your infra are below a certain dollar threshold. And if they violate any of those policies, you can flat out deny the provisioning, or you can add additional steps to require additional approvals for that provisioning and different activities that align to your organization's workflow. Of course, everything we're doing here is fully audited and tracked so that all of this information around approvals, denials, policies being passed or failed is all tracked within audit log information that can be read through your SIM or other reporting tools as required within your platforms. And with that, I'm going to just quickly show here. We can see that this apply did finish. We have some outputs showing what our website is and what image or version was deployed. And I'll turn this back to Tom for closing us back out. Thank you.
Thank you, Larry. That was great.
Thank you so much, Larry. So I've got to finish off, I guess, just to sort of echo what Larry had described. So at the end of our Terraform run itself, and we can flip back to Circle at this point, and as Larry has mentioned, the output is continuously streaming in your Circle job, so you're still getting that traceability the whole way through. If we were now to visit, so we were able right the way from sort of beginning to deploy, if you will, we looked at version 1.4.2. If we fire this in right now, this is now directed right the way through to our thing. And okay, a little bit, I might very well have wanted to sort of show a full screen with a waffle on it. I'm sorry, I'm guilty, okay. But we've got version 1.4.2 the whole way through now, and it's, we've in this case, we've admitted this as Terraform variables as output. Sorry, in order for us to sort of showcase this, but it's an incredibly powerful feature, to kind of flow this in between modules as well. And I think that's probably about everything for me to present. So I'm going to hand back to our MC, Chris. So I'll stop my share now.
Awesome.
Back.
Awesome. Let me find my slides here. Actually, you know what? No need to share the presentation. We're at time, but as promised, let's stick around for another minute or so to answer any questions folks might have. I know between myself, Tom, Larry, we threw a ton at all of you. That was a fabulous demo. Both of those demos were absolutely fabulous. In fact, I have a super quick question for Larry. Larry, is the cost estimation applicable to most cloud providers, AWS, GCP, Azure?
Yes, it is.
Fabulous, fabulous. Yeah, well, I'm willing to stick around for another moment or so. Would love to encourage our participants to ask any questions they might have, thoughts, musings, feedback on the demo. I thought it was brilliant. How to get
What questions can we answer?
I just need to ask Larry about his arcade machine at this point.
Yeah, it seems to always be a conversation starter. Plays all of, I think it's about 1,500 or so games on there. So everything from your childhood, whether it's arcade Teenage Mutant Ninja Turtles or Donkey Kong, it's on there.
Does it have the arcade Simpsons game that was popular in the early 90s? You know which one I'm talking about? It was in like every pizza chain in the United States. And I remember one time as a kid, my mother graciously gave me $5 in quarters. Now, like, you know, adjusted for inflation, early 90s, like this is no small chunk of change, $5 in quarters. And I remember we were in like a Pizza Hut or something, you know, circa 1993. And I got to the final boss. Which lo and behold was Krusty the Clown. And I was not able to defeat Krusty the Clown. And that still to this day kind of weighs heavy on my shoulders. So Larry, at some point I got to come over. We got to play some Simpsons arcade. All right. I think we might have a question. Oh, okay. We got some feedback from Cathal Garvey. I hope I'm saying that correctly. Not a question, but wanted to share a fantastic demo. I've learned loads. Thank you very much to the three of you. Awesome. Final call for questions. I just want to point out CircleCI has a very generous free tier. So if you're curious, you want to kick the tires, you want to kind of get your hands on the platform, we give everybody on GitHub and Bitbucket a free container. Another question, recommended references to recreate workflows shown. I believe we're going to share this deck for posterity. And so I imagine this deck, and Tom, correct me if I'm wrong, there's going to be a link to the repository that you used.
Yeah, that's right. So we'll have a number of resources on at the end of this for everyone, all the participants to be able to go off. And there's links for each of the partners here today. So Circle, ourselves, and Hashi, we all have some stuff in here. But right at the bottom of that, there'll be GitHub URLs for the code that was used for the infrastructure piece, as well as all of the orchestration stuff on the push side as well.
And just to speak from the Hashi side, the Terraform Cloud link in the document, the presentation that you'll get, you can sign up for free, create your free cloud account, and that will allow you to leverage that aspect as well as part of the code repo to reproduce this.
Amazing. With our powers combined. All right, everybody, I think we're going to call it here. This was great. Tom, Larry, thank you both so much for your time today. I want to thank all of our participants for joining. Hopefully you all found this valuable. Like I said, we're going to share this recording on YouTube, and we're going to make the presentation materials available along with the resources Tom mentioned at the end.
Awesome.
Thank you, Chris, Tom. Thank you, everybody, for attending and participating.
All right, everybody.
Thank you so much, everyone.
Cheers.
All right. See you again. Bye-bye.